Hey guys, how's it going? Hope you're all doing well. Today I'm going to be reacting to Where Did Earth's Water Actually Come From by the channel The Infographic Show. Now, I've done a couple videos from this channel on my channel before. The Infographic Show is an amazing channel. If you haven't seen them or heard of them, definitely go check them out. They cover a range of, just a range of topics. Basically, anything you can think of, from war to politics to the human body to, in this case, water and astronomy stuff, like where did Earth's water come from? Because I know a lot about space, I assume he's going to go into theories like it came from asteroids, with asteroids colliding with the Earth back when the Earth was young. But I don't know. Obviously, I haven't seen this video. I don't know exactly where he's going to go with this. But as always, it should be interesting. Let's just get right into it, see what we got.
Water, H2O, agua. It's the building block of life, essential for our survival and seemingly omnipresent. We take it for granted, but where did it actually come from? It wasn't always here. This is the story of where Earth's water actually came from. Earth is often referred to as a water planet, with 71% of Earth's surface being covered in salt or fresh water. Essentially, we're all sort of living on mountains sticking out of the water. This is all made possible because Earth is in the Goldilocks zone, close enough to the sun for water to not just turn to ice, but far enough away for water to not turn into steam. We're not the only planet in the universe in this mythological Goldilocks zone, but on average, most planets are either hot enough to transform water into little more than vapor quickly, or cold enough to leave it perpetually frozen. And of course, at one time, our wonderful planet was anything but hospitable. How did Earth form? Most media just shows it as a massive kaboom known as the Big Bang, and then the universe existed. But the real world isn't a cartoon. At least not that kind of cartoon. Here on the Infographic Show, we're digging a little bit deeper, and there was a huge period of Earth's development where it didn't look anything like it does today. After the Big Bang and the formation of molecules in the universe, Earth began slowly forming as what's known as a protoplanetary disk. A large surface of gas and dust started swirling together, pulled into place by the gravity of the sun. As the grains started interacting, they combined into clumps, and then those formed into the building blocks of a planet. But it was still the furthest thing from a place where anything could live. This period of active planetary formation was hot, very hot, likely far too hot for humans or anything else to survive there. There were few hallmarks of the planet we know today, but one thing was present: water. The molecules swirling around the planet included both hydrogen and oxygen, the building blocks of water. But the water didn't look anything like we know it either. It was kept in a constant state of flux by the heat, perpetually evaporating. So it was just water molecules spiraling amongst the debris. And without an atmosphere, they just drifted off into deep space as Earth remained a boiling hot protoplanet. But then something interesting happened. Earth was getting bigger and bigger, and that made it a target. The universe was a very volatile place at that point in time, with comets and asteroids spiraling around and hitting larger objects. Those objects often became part of forming the planet, or shaped them forever, and many of them may have had water frozen into them. Water that would then land on Earth, contributing to the building blocks of today's oceans. But first, some major things would have to change on the home planet. It was around 4.6 billion years ago when Earth had formed into a pretty solid planet and was starting to cool. But the surface was still largely molten, and massive volcanoes were starting to form and spew gases into the atmosphere. They included hydrogen, but also sulfide, methane, and massive amounts of carbon dioxide. Not suitable for anything to breathe, but enough to start cooling the surface and allowing water to get trapped on the surface, forming pools instead of evaporating into gas the second it formed. This process took over 500 million years, but around this time, maybe the most significant event in Earth's early history is believed to have happened. This is around when the earliest formation of water on Earth might have formed. But it wouldn't last because it's believed that around 4.5 billion years ago, Earth came closer to ceasing to exist than it has at any moment since.
Wait, what?
The Theia impact, also known as the Big Splash, is believed to be an event where the Earth was hit by a massive planet close to the size of Mars. Because Earth was still in early formation, it was flexible enough to incorporate the new body that hit it and heal, continuing to form while massive amounts of matter were ejected from the Earth and caught in its orbit, eventually forming another body that would orbit Earth to this day, the Moon. This would be the foundation of the tides Earth experiences today, and it was only the beginning of something much bigger. The finalizing of Earth's structure and the formation of the atmosphere allowed that water that existed on Earth already to solidify and become part of the planet. The temperature during this period could have been as much as 230 degrees Celsius, but it would slowly lower after this, and it's believed that small water oceans could have formed thanks to increased atmospheric pressure. But as the world cooled, much of the excess carbon dioxide was removed from the atmosphere, and our world started to more closely resemble the one we live in today. And evidence shows that Earth's water has been around for a shockingly long time. Is our water truly our own? Did Earth's unique ecosystem generate our own water and keep it to this day? It's possible, and there's evidence dating back billions of years. While no living species on Earth has been around that long, there are objects that date back to the formation of Earth, billions of years. Some of the oldest rocks ever discovered, pillow basalt, are found deep underground. Samples discovered around Greenland and Quebec are dated back to over 4 billion years ago during the early formation of Earth, and chemical analysis found evidence of water at the time the rocks were formed. This was the first indication that Earth may have had its own water since the planet's formation. But was it enough to create the world we know today? Rocks that survived from this period are exceedingly rare, and the pillow basalt samples discovered are hard to find as they were formed during an underwater explosion. But there are other substances that survived from that period. Zircons, hard minerals that are far more resistant to the conditions that wear down rocks. They also indicate the presence of water, which leads some scientists to theorize that Earth may have cooled sooner than we believe, meaning it could have provided an atmosphere where water could survive. But other scientists say that water isn't likely to have solely come from Earth, but from above. Earth's surface is heavily covered with water, but it is a bit deceiving. The oceans are deep, to us, because we're rather small. They only make up a small percentage of Earth's mass. The oceans themselves make up less than 0.25% of Earth's overall mass, with lakes, rivers, and frozen areas being only a small addition. Instead, the vast majority of Earth's water exists in solid objects, stored in the crust, mantle, and the core. These form hydrated minerals that are key to the forming of molecular bonds. It's believed that the Earth's core alone could contain as much hydrogen as 5 of our oceans. But there's no way to test that theory because the Earth's core is hot enough to destroy any type of survey technology that we've developed so far, which means scientists are left looking for other answers. Is Earth's water truly its own, or did it come from up above? The consensus is that Earth was definitely hit by a lot of extraplanetary objects over the years, some of them massive. Just ask the dinosaurs, but you might have trouble getting some of them on the phone. These asteroids, meteors, and comets sail through the sky at a rapid rate, no doubt freezing any moisture on them solid. As it makes impact, the heat inevitably melts it and transfers anything that hasn't evaporated to the planet that it landed on. The only question is, how much? No one's sure, not even the scientists. There are many theories, including one that claims Earth became what it is today by eating other planetoids. Cannibal planet? Not exactly. The theory states that around 4.5 billion years ago, when Earth was still much smaller, it was repeatedly hit by icy planetesimals that were then incorporated into its landmass. This allowed it to grow to its current size, adding up to 40% of its current mass. But it also retained much of the water, both in its body and on the surface. To back up this hypothesis, scientists have studied the isotope ratio of water in the Earth and compared it with meteors that are found in the asteroid belt. To get the evidence, they went pretty far, including collecting samples on the Apollo 15 and Apollo 17 missions. This was the best evidence yet that water was already present on Earth before the formation of the Moon. But this theory doesn't have unanimous support by any stretch. Scientists who are skeptical of the early water theory point to the noble gas isotope ratios of Earth's atmosphere, which differ dramatically from the ratio in the mantle. This would indicate that they were likely formed from different sources and at different times. With billions of years to play with, some scientists theorize that while water was present on Earth from an early date, this would just be a small fraction of the percentage that we have today. And our studies have barely begun to analyze the material that dates back to before the Moon was formed. So the question is, when did Earth get all this water? It takes a pretty big explosion to change everything, and it doesn't get much bigger than the forming of the Moon. So a third theory, backed up by analyzing isotope ratios in the element molybdenum, theorizes that this near-Earth-shattering impact was the moment that Earth got the majority of its water. The source of the collision, the lost planet known by many as Theia. might have carried a massive amount of water with it after originating in the colder outer solar system. When it hit Earth, it massively lowered the temperature of the planet and allowed water to thrive there. A theory backed up by studies showing the components of molybdenum originate from the outer solar system. But what if it wasn't one impact, but it was a lot of them? The other theory supposes that rather than the water on Earth coming from one massive impact or occurring naturally on Earth, it was a series of strikes by interstellar objects during Earth's early formation. With each strike, the Earth was hit with a little more water, which seeped into the still porous surface. As the planet hardened, the frequent strikes would add more water to the surface, shaping its current form and eventually creating the map of the world we know today. As the solar system took shape and the activity calmed down, the strikes slowed down as well and left a stable planet filled with water. But not all interstellar objects are the same, so let's look at the likely suspects. Most scientists believe asteroids are the primary source of Earth's water, ranging from the massive ones that hit the Earth early on to smaller ones. The oldest meteorites in the solar system, known as carbonaceous chondrites, have isotope levels that resemble seawater. This includes hydrogen and nitrogen isotopes that are surprisingly close to Earth, and some of them date back to the days of the formation of Earth, and were found to have liquid water inside them. So, how did they accumulate this water? Analysis indicates that it might have been formed when hydrogen atoms that are loose in the solar wind combine with oxygen already present on an asteroid, forming the building blocks of water. But while asteroids and meteors have a lot of common components, they don't have a high level of water present. So all eyes turn to another suspect. Comets don't reach the same size as the largest asteroids, and they're not usually as devastating upon impact, but they have an advantage over asteroids when it comes to this theory. They're made primarily from water, a combination of ice and space dust. They shoot through the solar system and can be kilometers long thanks to their massive tails. Their trajectories often bring them into Earth's orbit, but despite this, it's not considered likely that they're the primary source of water on Earth. This is because their isotope ratios, particularly of deuterium to hydrogen, are massively off from the makeup of ocean water. Several famous comets like Halley and Hale-Bopp have been analyzed, and the consensus is that while comets may have contributed to Earth's water, they likely provided no more than 10% of the current water levels. So, what's the consensus? Some scientists believe that Earth's water formed naturally over a long period when our world was initially forged. Others believe that it was delivered to us in one massive impact that formed the Moon, and yet others theorize that a collection of water-rich asteroids delivered it over a longer period of time, slowly shaping our world into what it is today. Why can't they come to a conclusion? Because it happened so long ago that finding evidence dating back to those ages is like finding a needle in a haystack. And there is evidence pointing in favor of all three hypotheses. And it is possible that all three might be a little bit right. This all happened long before a single human or even a single multi-celled organism walked on Earth. It was part of the formation of a chemical stew that created the exact right conditions for life to form and evolve. And it's likely that there were contributions from all three sources. We know that there was some water present on Earth before it was fully formed, but it's not clear how much of it stuck around. We also know that the best theory for the formation of the Moon relates to a massive collision with a planetary object, and that planet likely had its own water. And it's confirmed that many massive asteroids have hit the Earth in the billions of years that came after. Without one of those impacts, it's likely Earth would not be Earth. And that can be seen across the solar system. We only have to look all around us to see how the conditions that made Earth what it is are near impossible to duplicate, because we're not the only body in the area with evidence of water. But the presence of water doesn't guarantee anything. The Moon is believed to have significant amounts of lunar water, with some present in lunar volcanic glass bubbles. This water is very similar in makeup to the water we have on Earth, and it can be found in lunar rock samples. The difference is, the Moon doesn't have an atmosphere, meaning the water on the surface will be quickly whisked away, and the situation is even more different elsewhere. Mercury, the planet closest to the Sun, doesn't have any visible water on the surface, and for the longest time it was thought as a non-volatile planet. However, Mariner 10 space probe was able to withstand the blasting heat and found all the building blocks of water. It was rich in all the elements needed to create water, but it was intensely hot and lacked an atmosphere, instead having only a thin exosphere. So if it had formed anywhere else, there is a possibility that it could have been a place for standing water and potentially life. But Mercury isn't the most intense place in the solar system.
That's Venus.
Is known as chaotic, hot, and a toxic place where the atmosphere locks in the heat and makes it a deeply inhospitable place for life to exist. That makes water wildly unstable on its surface, with most of it evaporating quickly. But that doesn't mean it was never there. It's believed that early in Venus's existence, it may have had a massive H2O store and lost most of it over the billions of years due to the atmospheric conditions. But there is one planet that fascinates observers more than any other. Mars is relatively close to Earth, as well as to the asteroid belt. And while it's significantly colder than Earth, it has the most similarities to Earth of any other planet in the solar system, with one exception. It doesn't have an atmosphere, which makes it impossible for anything to currently live there, at least from what we've seen. Due to its cold temperature and the lack of an atmosphere, it also has no flowing water on the surface,
very thin
with all its
atmosphere.
water coming in the form of ice. But that makes it easy to observe, and scientists believe that the surface of the poles consists almost entirely of water, just like ours. This is a massive store of water, as much as 30 meters deep in some places. So the question is, what's down there? And what did it used to be? Mars has had more unmanned missions on it than any other planet for a number of reasons. For one, it's a lot easier to explore than Venus or Mercury, and it's also a lot easier to get to than Jupiter or Saturn. But beyond that, scientists believe it has all the hallmarks of a planet that doesn't have life on it, but could have at some point. The topography of Mars indicates it was shaped over millions of years, and there are many finely carved areas on the surface that look like they could have been formed by flowing water millions or billions of years ago. So what happened? A growing theory suggests that Mars could have had an atmosphere at some point, but had it stripped away by a massive cosmic event that caused catastrophic effects on the planet. This would have led to the evaporation of most of the surface water, as well as the extinction of any life that formed at the time, and left any remaining water frozen solid after exposure to the coldness of space. Which means that when manned missions to Mars eventually arrive, whether they be manned by a national mission or a massive corporation staff, they'll be looking hard for evidence of what came before, and that could provide significant insight into our world's formation. The ratios of water on Earth and Mars are very similar. The two planets are about the same size, and there are enough similarities that they could be sister planets. But while Earth's atmosphere allows it to keep stable flowing water on its surface, Mars is essentially frozen in time since whatever happened to strip it of its atmosphere. This is a key part of why countries keep sending unmanned missions to Mars to collect surface samples. But rovers and robot dogs can only do so much, and so the race is on to land the first manned mission to Mars, and get them back, of course. That's important too. But back on Earth, there's another reason people are concerned about the question of where Earth's water came from. Earth's climate changed a lot at the beginning of its existence, and it may be changing again now. Temperature records are broken every year, and the poles are melting, and water levels are rising, threatening to wipe away low-lying areas near the water. This not only includes many coastline homes, but entire cultures built on islands. What's causing this? That's a debate for another video, and we're sure everyone will handle it with as much decorum as they usually do on cable news. But regardless of what's causing it, it is happening. And understanding where our world's water came from might be the key to figuring out how we can preserve it. But of course, just because water is everywhere doesn't mean everyone has water. The changing levels of water pose a threat to the environment, but another threat is the increasing inaccessibility of clean water. Industry, pollution, deforestation, and other environmental conditions have cut off or polluted many natural water sources, resulting in water needing to be purified to be potable. And Mom knew what she was talking about when she said, "Keep drinking water." So any place where clean water isn't available is likely to be a massive health hazard. And the most interesting part is water seems to be near universal. Some of the isotope levels in water found on other planets and other sources is different from our own, but the basic building blocks of H2O are intact. This means the odds are that water isn't only in our solar system, it is likely across the universe, anywhere that interstellar bodies are carried by the solar winds, bearing frozen ice. That means that while there might not be any habitable worlds in our solar system, there are as many as 100,000 million stars in the Milky Way galaxy alone, surrounded by an untold number of planets, all of which have the same chance of being habitable for humans. And we haven't even begun to explore them. And on any one of those potential habitable planets, there's a good chance that an alien life is sipping a long, cool glass of water right now, just like we are. Want to learn more about why water is so essential? Check out This Will Happen If You Don't Drink Water for a Week, or check out this video instead. Water.
Wow, okay, so where do I start with that? Hey guys, I'm back with, I guess you could say, the rest of the outro for this video, because I needed to take a minute and think about what I wanted to say, because I didn't say everything I wanted to say during the video. It just kind of slipped my mind, but I guess for starters, because there was a lot in here that I wanted to address, but for starters, like I said, I figured he would go there with the, asteroids and comets colliding with Earth in the millions and billions of years throughout Earth's history, contributing to the water. But I didn't know about the collision that formed the moon contributing to the water. I had already said all of that. But I also wanted to address that Venus, I've always found it interesting that Venus and Earth, I have always considered almost kind of flipped throughout the billions of years of their history. Like, Venus used to be much more Earth-like, and Earth used to be much more Venus-like, maybe even worse than Venus. It said something in there, like, maybe not worse than Venus, it said something in there like 500 and some odd degrees Fahrenheit, which is about the temperature of the bright side of Mercury, the side of Mercury facing the sun. So maybe more like Mercury than Venus, but it was a magma ball. And then Venus was had a lot of liquid water on the surface in its early days, but being closer to the sun and the atmospheric conditions just all evaporated, leaving just a bone dry surface in its wake. And I also found it interesting when he talked about Mars used to have water, and Mars still, like I said, like he said in the video, and that I also mentioned, Mars still has potentially frozen liquid water at its poles, both North and South Pole, that is basically inaccessible, at least to us currently. But he talked about Mars once having an atmosphere, and that atmosphere being stripped away, and I thought, that's because Mars doesn't have a magnetic field like the Earth, because Mars's outer core isn't active, it's not spinning like Earth's is, so it's not creating that magnetic field protecting it from the solar rays and the solar storms, and throughout billions of years it just stripped away at Mars's atmosphere. And Mars does have an atmosphere, just as a very thin atmosphere, and it's constantly being stripped away by the sun's rays hitting it. So I thought all that was interesting, and yeah, all that stuff, just really a lot of what I wanted to say just slipped my mind the first time. So I'm back here with this outro, and I guess that's all I have to say, because there's a lot of interesting stuff in here. Like I said, this stuff really fascinates me. So if you want to see more, like, comment, subscribe. It really help out the channel. And if you have any suggestions, comment those below as well. And I guess I'll see you in the next one. See you guys.